It's Douglas's method again. We're here solving simultaneous equations, but this simultaneous equation is in a different form. The normal simultaneous we will get two linear equations. So we'll get this equation being a linear equation and this one also being linear. But as you can see, the top one, equation 1, is not a linear. How we know that? Because the highest power of x is not 1, it's 2. So therefore, what this will give us, when it is that we have a power that's greater than 1 as the highest power of x, it's going to give us curves. And in this case, this will give us one curve. So, because the highest power of x here is 2, we know that this is not a linear equation. It will never give us a line. This is going to give us a curve. However, this gives us a line. Now, CSEC will also ask us to solve this to find out what are the values of x and y. So we can find that easily. How we do that? The first thing is that we make both equations be written in terms of y. And what do I mean by in terms of y? I mean y equal. Y equal. That's what in terms of y mean. Y equal. Y equal. So the equation must be written with y equal in terms of y. So here we go. After doing that now with any equation like this, I will do that the same. Write it in terms of y equal. What I do next is that seeing that both of these are the same values of y, it means that equation 1 is equal to equation 2. So what I then do is that I'll make both equations be equal to each other. I'll equate both equations to each other. So it is going to give me 2x squared plus 5x minus 3 is equal to x plus 27. So I make both equations, the nonlinear equal to the linear. Or if you want to say the quadratic, equal to the linear. Now I want this over here, because what I want here is I want over here to become 0, so I can solve. I can use a quadratic formula then to solve, or I can use the factor method to solve. So I'm going to try it by the factor method. Now by the factor method first, in order to get over here equal to 0, I have to get rid of the x and I have to get rid of the 27. So here we go. So we're going to have 2x squared. Now this positive 5x will be like terms with this 1x here. So what I'd have to do now, because I have to get rid of this x from over here, I'm going to have to subtract it over here. And what I do to one side, I do the same thing here. So I have plus 5x. Now remember, I'm subtracting x over here. So I need to subtract it from here. Minus x. Now and the negative 3 won't, we don't touch the negative 3. So therefore I write about the negative 3. Now I want to get this negative 3 here and this positive 27 will be like terms because they are both constant terms. So therefore, in order for me to get this positive 27 removed from here, I have to subtract it from over here. And if I subtract it from over here, I have to subtract it over here as well. So I'm going to get minus 27. And because I'm subtracting it from both sides, over here will be equal to 0, which is what I want. Now I simplify this now. There's nothing here with group with this 2x squared, so it comes back 2x squared. Now look at this now. Positive 5x minus x. This is negative minus 1x here. It says 5x minus 1x. That's positive 4x. Negative 3 minus 27. That will be negative 30. And that is equal to 0. So we have formed our quadratic equation. Now I'm going to use the factor method to try and solve this. Now the factor method tells me that I must take the x squared term and the constant term and multiply them. And remember, I'm talking about terms, so terms come with signs. So I'm taking a positive 2x squared, and let me write the x better, positive 2x squared, and I am multiplying it by constant term is at negative 30. So I multiply it by negative 30. So I'm going to get negative 60x squared. Now I need two numbers. I'm going to work with the numbers just a little because remember, once I find the numbers, I can just attribute or basically I just attach x to both of the to both terms. I have to give me the x squared, just like normal factorization quadratics. So I'm just going to work with the numbers a little bit. So I need two numbers that when I multiply it, I get negative 60. But remember, the rule says that when I multiply the two numbers, the two factors that I get, I must get a negative 60. But when I add it, I get a positive 4. I must get by the term of b. Remember that this is a, this value, this is that's representative of a, as in the general form of the quadratic expression or equation. This represents b, and this represents c. So when I multiply it, I must get negative 60. But when I add it, I must get positive 4. So let's list some numbers here now. If I have negative 1 times 60, when I add negative 1 by 60, I cannot get positive 4. Negative 2 by 30, won't get positive 4. Keep on listing. Negative. This might be a long process, but you just go through it to eliminate everything. Negative 3 times 20, I won't get positive 4. It's positive 4 that I need. So continue listing. Negative 4 by 15, we're getting closer to the 4 because negative 4 plus 15 would give us positive 11. So we're getting close to the positive 4. It's coming down. Continue. Negative 5 times 12. Now negative 5 plus 12 will give us positive 7. This will remember, this will give us positive 11. This will give us positive 7. Continue listing. Negative 6 times 10. Negative 6 times 10 gives me negative 60. Negative 6 plus 10 gives me a positive 4. Very interesting. So therefore, what I do now, seeing that I found the factor, the two factors, it will be negative 6x multiplied by 10x. Because it will give us what, x squared, which we need. So seeing that I have now found the two factors, I will now replace the two factors with the term of b, showing the sum, not the product, the sum of the two factors. So I'm now going to have 2x squared minus 6x, because remember that's what I got down here. Now it shows the sum, so I'll have now plus 10x. Remember, when I multiply this, I'll get negative 60x squared. When I added it, I'm going to get 4x minus 30, and that is now equal to 0. So I'll now replace the bx with the two terms by addition. So what I do here now, I pair off, factorize. So I pair that off there. So factorizing this, highest common factor of 2 and 6 is 2. Highest common factor of x squared and x, or highest common factor of variables with and variables with a power is the variable with the lowest power. Let me write this x better. So this is x to the first power, this is x to the second power. So the variable with the lower power or the lowest power is the highest common factor. So therefore this will give us 2x here. Also going to leave in the bracket 2x, what multiplied by 2x gives us x. Or we can say how much times we need to multiply 2 by 2 one time. How much more x's do we need? We have this x to the first, we need to go x to the second, we need an additional x. Now here we have how much times we need to multiply, can I write by the minus sign there. How much time we need to multiply 2 by 6 to get 6? 3 times. And we shall need to multiply x by to get back x. We don't need to multiply it. So we can close that bracket. Plus, look at this now. Factorizing this part. Highest common factor of 10 and 30 is 10. Do we have a highest common factor for variables? No. Why do we not have that? Because the negative 30 does not have a variable of x. Remember, highest common factor must be found in each term. So if I don't have an x here, I cannot have a highest common factor of x here. So 10 is my highest common factor. What do I multiply 10 by to get 10x? X. What do I multiply 10 by to get negative 30? Negative 3. And that's equal to 0. So what I do now, I see that I have this, by the way, 1x is really x. So I don't really need to write the 1. So I have two brackets that are the same. So what I do now is I group the other two that are outside the bracket in a bracket. So I have 2x plus 10. So I group those in a bracket, and I write back the bracket that was there. That's common, x minus 3, and that's equal to 0. So what I do now, I now equate both of these to 0 and I solve for x. So splitting here, so we have 2x plus 10 equals 0, x minus 3 equals 0. So here we go now. Want to find x, so I have to quote unquote move this 10 over r, subtract 10 from both sides. So I have 2x equal to 0 minus 10. 2x is equal to negative 10. Solving for x, divided by 2 on both sides. 2x over 2 equal to negative 10 over 2. So we have x is equal to negative 5. So that is one factor. Next one, we want to get this 3 over here to get x by itself, or because we're subtracting 3 here, I have to add 3 now to both sides, and then the opposite to both sides. So I have x equal to 0 plus 3, x therefore is equal to 3. So I have my two values of x, which is what I need. Now what I need to do now, because I have my two values of x, I need to find the y values that correspond to these values. So therefore, what I do now, remember, when you're solving simultaneously, solving for both x and y, we're solving for two different values, two different variables, sorry. I only know the values for one variable. So I have to go now and find the values for y. So I say when x is negative 5. Now, when what I'm going to do, I'm going to use the linear equation because it is simpler to find the value of y in the linear equation. So I say when x is negative 5, so I write by the linear, x plus 27. So I now replace the x here with negative 5. So y is equal to negative 5 plus 27. And we know this is really saying 27 minus 5 because we can write it the other way. We know that y is equal to 22. So when x is 5, y is 22. So when x is equal to 3, do the same thing, put it in the linear. So write back the linear, y equal x plus 27. Replace the value of x, y is equal to 3 plus 27. And we know that that is equal to 30. So we have our two values. And we can write our statement afterwards that when x equal negative 5, y is equal to 22. And when x is equal to 3, y is equal to 30. And that's the end of that. Alright, so therefore this is how we'll solve the linear and the nonlinear as a simultaneous equation.